Special thanks to Indeed for sponsoring a portion of this video. When you finally got the right answer, the stars align and the numbers add up. The fastest way to reach your potential is with the right people in place. If you're hiring, you need Indeed. With Indeed, you can attract, interview, and hire all in one place. Indeed partners with you on every step of the hiring process, so you can find talent with the skills you need through tools like Indeed Instant Match, assessments, and virtual interviews. With Instant Match, candidates you invite to apply are 3 times more likely to apply to your job than those who only see it in search, according to Indeed data. Listen, get started right now with a $75 sponsored job credit to upgrade your job post at Indeed.com/StarTalk. Get a $75 credit at Indeed.com/StarTalk. Can I say it again? Indeed.com/StarTalk. Offer valid through December 31st. Terms and conditions apply. You need to hire. You need Indeed.
That time again, Chuck.
Yes.
Okay.
I'm excited to know what we got going today.
We're going to just talk about oxygen.
Oh, man.
What's the matter?
Dude, normally you come to me with some like super exciting stuff like, today we're going to talk about the moon and albedo. Do you know what albedo is? No, man, what is that? That sounds really cool.
I'm sorry oxygen doesn't excite you, but maybe by the end of these 10 minutes it will. That's all I'm saying.
All right.
Give it a chance,
Well, listen, I give oxygen a chance every day.
Okay. Okay. Many people who have never had atmospheric chemistry,
right?
They know that we breathe oxygen to survive. We know this.
Right.
But not everyone knows how much oxygen is in our atmosphere.
Okay. Well, already, now I'm interested.
Right. So the first guess is, well, it's all oxygen.
Right.
Of course, we're breathing oxygen. That's not the case.
Right.
Most of the air we breathe is nitrogen.
Nitrogen, okay.
Which has no value in its gaseous form as we inhale it. So we just inhale it and then exhale it. Okay. Nitrogen is 78% of the air we breathe.
Wow.
It's most.
Did not know that.
Did not know that. Okay. So now oxygen is between 20 and 21% of the air we breathe. So it's about 1/5 of the air we breathe.
Gotcha.
All right. Right. So just let me put that out there, first of all. Second, as you know, trees and other photosynthesizing life makes oxygen.
Right.
One of the delusions of the early Star Trek series was you ever notice, I've said this in other explainers, they never wear spacesuits when they visit planets.
Every time they come down to a planet, they're just like, well, isn't this nice?
No, so they check. It's oxygen, nitrogen atmosphere, Captain.
It's a Class M planet.
Right. So then they go down and it's got oxygen. As though in the mix of all the planets that are out there, some of them will just happen to have this mix. And so it'll be just fine to be human and then walk down on its surface. Okay? All right. But if you think it through, the entire source of our oxygen is green plants. If you take away the green plants, oxygen is highly reactive as a chemical element. And so the oxygen that's in the atmosphere will glom on to other ingredients on Earth's surface, and it will systematically drain out of the Earth's atmosphere, leaving us with none. So if you find a planet that has sustained oxygen,
right,
that is evidence of something generating that oxygen, and in our case, it's plants. It could be some other mechanism, none we have ever dreamt of or divined. But if you find a planet with oxygen, it's going to have plant life.
Wow. Right.
Or something that is generating oxygen in real time. And in the planets they went to, that was never discussed. Because I think they just believed in the planet lottery, some planets have oxygen and others don't.
And you know what's funny that you say that? Many of the planets that they beamed down to were very Mars-like. So they're very rocky. There's no vegetation at all.
I think the rocks are easier for the prop people to make than whole trees with plumage. Right. Yeah, it was very barren. Correct. You remembered this. So that's one little thing about the oxygen I put out there. Okay. Also, by the way, on the planets they landed on, they were never sort of bounding the way the astronauts did on the moon. Those planets all had about 1 g, just like Earth.
All right. Yes.
And the atmospheric pressure was about that of Earth.
The same as Earth.
There's some planets that are the same size as Earth and the same gravity as Earth, but the atmospheric pressure is 100 times that of Earth. So they'd beam down and just get flattened.
Flattened like they got hit with a fly swatter.
Yeah, basically.
Wow.
Yeah. Okay, so more about oxygen. There's this belief that oxygen is flammable.
Okay. Maybe that's
not.
because every oxygen tank I've ever seen has the word flammable written all over it. That might be why people believe that. You go to any hospital, you're going to see a tank. You're going to see a tank in the corner, and on that tank is going to be a little fire emoji with the word flammable.
Is that what's on tanks? Emojis. I didn't know that. Okay. All right. So, I should clarify what's going on there.
Okay.
Okay. Oxygen promotes combustion. That's why they have those labels there. So, this won't happen today ever, but in the day, you walk into a hospital smoking a cigarette. Okay? If you go into a hospital room.
Ooh, wait a minute. Now I'm just seeing a doctor smoking a cigarette.
Scalpel.
With a hole through the mask. Scalpel.
Wait, let me cauterize this.
Exactly. Hold on. There we go. Oh, Jesus. I think I dropped my butt in this guy's open abdomen. Anybody seen a cigarette butt?
And you got that smoker's voice, too.
Exactly. Oh, my God. Your doctor sounds like a diner waitress. Well, listen, dear. I don't want to give you bad news, but here's the lowdown, hun. Let me get you a coffee, and then we'll talk about this.
Talk. The smoking New York diner
doctor. Oh man. Okay.
All right. So here's what happens. It promotes combustion. So if you're in a room of oxygen and you bring in a lit cigarette, the cigarette would instantly go up in smoke.
Wow.
Instantly. I mean, it would go from the lit spot, but it would go, and the whole thing would just ignite instantly.
Gotcha.
But you're not going to ignite the gas in the room. That's my point.
Aha.
The oxygen itself does not burn.
So oxygen, I was about to say, it's like a non-burning accelerant.
Okay, I can, yes, sure.
I mean, I'm trying to make sense of this because it's
I'll allow that, but I think in firefighter talk, accelerant
burns.
Might mean something else. Yeah. Right. So this is what happened. Apollo 1.
Uh-oh.
Apollo 1. All right. Nobody's ever heard of Apollo 1 because it never went anywhere. It was that through Apollo 6, I think it was a set of designs of the capsule that would take 3 astronauts to the moon. There they are on the launch pad, on a testing pad. And in the capsule is pure oxygen.
Whoa.
Here's why. Because if they had an oxygen-nitrogen mix, you would have to pressurize the inside to equal atmospheric pressure.
Right.
So that you'd have the right amount of oxygen that you're accustomed to breathing. If you do that, you have to overbuild the strength of the capsule to contain 1 atmospheric pressure against the vacuum of space.
Gotcha.
So all the joints, the bolts and the hinges and the door closures and the window would have to be extra strong. Gotcha. So they said, why burden ourselves with this? Let's instead put in pure oxygen. Then we don't need to have it at full pressure.
That's actually kind of brilliant.
It's brilliant. It's brilliant. Now we can go much lower pressure, but it's all oxygen. So now you take in a breath, it's less total air, but it's the right amount of oxygen that your body's expecting. Okay? All right. In that capsule, there was an electrical fire.
Oh.
There was a spark that immediately burned all of the insulation, their suits, and they could not open the hatch in time. All 3 astronauts were burned to death.
Oh, gosh.
Yep.
That is just awful.
Yeah, it's terrible. So again, it's accidents like that where we think the oxygen was burning, but that's not what was burning. The oxygen enabled everything burnable to burn,
continue to burn.
The astronauts themselves. Correct. We lost 3 astronauts in that fire.
Damn, that is, oh my God, that's just terrible.
Right.
So now what did they do to, listen, because let me just tell you, let me just say this. First of all, it's a tragedy, and I would dare never infringe upon the sanctity of those men and their lives. But I will say this. If I'm the next 3 astronauts, I just quit the space program.
No. Here's what they did. Instead of saying, okay, let's try Apollo 2. Okay. No, what they did was they scrapped 6 Apollo designs and came up with Apollo 7. I think it was 7 or 8. No, Apollo 7. And so they were nowhere near what that design was by the time they had the next vessel in place.
Okay. All right.
That would have satisfied you, I think.
Yeah.
So anyway, so that's another thing with oxygen. Now, here's another one. You ready? In the movie Jaws.
Okay.
There's a tank of oxygen.
Yes.
On deck at the end.
Right.
And the captain, I think Richard Dreyfuss' character bumps into it and he says, watch out! That's oxygen. Okay. All that mattered for the movie was that what was in the tank was compressed gas.
Right.
But they're saying, watch out, it's oxygen.
Right.
Oxygen. So what happens? How do they finally defeat the great white shark? Okay, I forgot which, it's been a while since I've seen the film. One of them, I think while the shark is munching on the boat, takes that oxygen tank and shoves it into the mouth of the shark.
Right.
Then dives off the boat. I'm making some of this up because I don't remember the details, but the shark, you can see the tank in the shark's mouth. The guy takes his high-powered rifle, shoots the tank, and the tank explodes, blowing the head of the shark off, and then peace reigns in Nantucket, or wherever the hell this was.
Yep.
Okay. So what mattered there was not that it was oxygen, but that it was gas under pressure, and when you punched a bullet hole in it, probably it just would have been a hole and would have gone psst.
I was going to say, the shark should have just shot off into the distance.
Yeah, he would have had a little retro rocket.
Little rocket mouth. Shark has rocket mouth now, and it's just like.
So that's probably what would have happened. But if this tank is not structurally sound and it can't accommodate a hole, it could conceivably blow up. But it blew up not because it had oxygen in it.
Right.
Because it was gas under pressure. So that's different from if you leave your gas in your stove on and all your windows are closed and you go out and you come back.
Right.
Now there's gas everywhere in the house. A spark won't just burn what sparked. All the gas will now ignite and explode. Right. And that's the difference between methane gas, which is flammable, and oxygen gas, which is not.
Right. And, and the other difference is normally that's kind of like insurance fraud. But
yes. Yeah. Okay. In the old days, I don't know if there's as much of that today.
Yeah, they got too much forensic science.
Too much science.
They got too much science. It's your people. Your people screwed it up.
We can science the shit out of whatever you just did.
I can't collect the insurance on my failing business now, thanks to you guys.
Ass in jail. So, a couple more things. Okay. As you may know, plant life likes carbon dioxide.
Of course.
It absorbs it. Okay, and that carbon becomes part of the fibers of the wood, and out comes oxygen, which we breathe. Okay. If you have too much plant life, and it creates, let's call it excess oxygen.
Okay.
Let's say 30% oxygen in the atmosphere. And there are calculations that do this which I can't quote precisely, but just some number above the 21% that we now have.
Right.
Take it to 30, 40, 50% oxygen. Imagine a world where plants are just pumping this out and they're loving it. Okay? In that world, forest fires never end.
Oh, that makes sense because they're being fed by oxygen all the time.
By oxygen, correct.
So you have
there's
the
a threshold.
fuel of the wood, and then the oxygen is also, fueling it too.
So in a way, it's self-correcting. Too much plant life creates too much oxygen, so that the next lightning strike will take it out, preventing more oxygen from coming in.
Oh wow, it's its own check and balance.
Correct. So it's just interesting to think about how you end up pegging oxygen at one level versus another.
Interesting.
One other thing, and I think we talked about it in our surface area explainer. Insects most of them don't have lungs the way we think of, we breathe in and we have lungs and that's how we get our oxygen. Insects, many of them rely on absorbing oxygen through their surface area.
Right.
Okay.
Which is why they never need breath mints. But yeah.
That's right. Is that right? Thank you for telling me that. Okay. So if you have more oxygen in your air, this is like rocket fuel for them.
Wow.
And they can grow bigger.
Oh.
Because when you're bigger, your surface area to volume is lower. But if you have, we did that in an explainer. You have to dig that one up. If you're bigger, you have more volume to your surface area. So now you're not going to get enough oxygen to feed your fat body. But if the oxygen levels are higher, you can. Right. And so that's why you had those huge dragonflies back at the time of the dinosaurs.
Right.
Okay. Oxygen levels were higher back then. You had these huge insects. So oxygen levels have consequences in the biota of Earth.
Nice. Wow. So who knew that all of this? Who knew all this about O2?
Exactly. And oxygen wants to combine, and so combines with itself best. So you have an O2, two oxygen. And one last thing. People talk about humans wrecking the Earth. The only species ever to change the ecosystem of the Earth. That is just false. The creature that had the greatest effect on the climate and conditions of the Earth were the cyanobacteria. When was this? 3.5 billion years ago, something like that. At that time, Earth's atmosphere was mostly carbon dioxide. Hardly any oxygen at all. They take in carbon dioxide and spew out oxygen.
Wow.
And they built the oxygen supply of our atmosphere to levels that were caustic to animals that don't like oxygen.
Right.
So this killed off entire branches of the tree of life who were doing just fine in their carbon dioxide atmosphere. But it enabled other forms of life to rise up that would exploit the oxygen for their own benefit.
Wow. So why can't we just use cyanobacteria as a carbon scrubber for our current situation where we have to mitigate the amount of carbon in the atmosphere?
Yeah, that's a good, okay, so sure. You have to watch out for unintended consequences.
Right. Because guess what? We already saw one unintended consequence of cyanobacteria. Thanks, cyanobacteria.
It's, who knows? Should probably get people to look into that. To have biological CO2 scrubbers, which is what plants are. Right. But again, they're putting more oxygen in the air, and that also has consequences. So, yeah.
Wow, that was great.
Anyhow. You got it, dude.
I started off saying oxygen was boring, but, I was wrong.
Yeah, and by the way, if oxygen were actually flammable, every time you lit a match, it would just burn. Your air would burn out.
That'd be kind of cool.
Or you could just pump oxygen through the gas, right? Your gas stove. But no, we don't, because it's not flammable. That's all I got to tell you about oxygen.
Yo, that was enough.
That's enough.
That was enough to, hey, yo, I love it.
All right, dude, that was
flammable.
yet another explainer. Always good to have you there, Chuck.
Always a pleasure.
We need you to bring some levity to what comes out of my mouth. So, all right, a bit of StarTalk explainer, stuff you thought you knew. Neil deGrasse Tyson signing out. Or keep looking up. That's my sign.